Hello, welcome to the first module of the video course Introduction to Data and Big Data. How much data is big data? In this module, you will find the answer to this question. That is, you will understand what big data is and how organizations, as well as individuals, can manage and leverage big data. Module objectives. By the end of this module, you will be able to explain the concept of big data, describe the key elements of big data, identify the fundamental building blocks of big data analytics systems, analyze the need of big data, and explore the current trends in big data analytics. Data vs. big data. Data is the raw material which is used as an input in computing systems to produce meaningful information and knowledge. It is generally in unorganized form and in the form of numbers, words, sound, images, video, and so on. The pace of digitization has tremendously increased the number of data resources and the rate at which new data is being created, or in other words, the volume of data is increasing. Quintillion bytes of data are created every day. 90% of the available data has been created in the last 2 years. To help manage and extract value from these huge chunks of data, big data comes into being. Big data is also data that describes and transfers a large volume of raw data. It is managed by organizations to improve the performance of their applications. Organizations can take prompt and crucial decisions with the help of big data. A brief history of big data. The history of the term big data may be short, but its foundation was laid a long time ago. From an analytical engine by Charles Babbage in the 1830s to the 21st century, supercomputer throughout the fascinating and revolutionary journey of computing, big data has always excited. Here is a list of events that gave rise to big data that we see today. In 1871, Charles Babbage invented an analytical engine. In 1937, IBM created punch card readers. In 1943, the British developed Colossus, a data processing machine. In 1965, the US government decided to build a data center. In 1995, first supercomputer was built. In 1998, the term big data was coined. In 2005, Yahoo created Hadoop. What is big data? The size of data in a big data is difficult to be stated, but it can be considered that the data consists of billions or millions of rows and columns of records. In other words, the term big data is used for huge datasets. Big data datasets may contain data in structured, semi-structured, or unstructured formats and are impractical to manage with traditional software tools. The sources of big data are smartphones, smart devices, social media apps and websites, emerging technologies in medical diagnosis, etc. Technologies such as Hadoop, NoSQL, Excel, Scoop are adapted to analyze and process big data to gain insights for better decision making and strategic planning. Characteristics of big data. Specifically, big data relates to data creation, storage, retrieval and analysis that is remarkable in terms of volume, velocity and variety. Huge volume. Big data is all about huge volumes of data generated by machines, networks, and human interactions on social media. High velocity. The flow of data from different sources is massive and continuous. This real-time data helps to make valuable decisions, which provide strategic competitive advantages. Diverse variety. Big data can be in different forms: structured, semi-structured, and unstructured. Fine-grained resolution. Deep, useful insights about the data can be gained by processing big data. Flexible. Dataset fields can be customized and added. Types of big data. Big data can also be defined as the collection of structured and unstructured data resources. Let us discuss these data resources briefly. Structured. These data resources are organized in accordance with specific formats. They are stored and managed in relational databases such as MySQL, Oracle, and Microsoft Access. The information contained in structured data resources is presentable and easy to understand. The data generated from enterprise systems is an example of structured data. Unstructured. These data resources do not have a specific format. They are disorganized arrangements of data and are difficult to manage and extract value from it. The data generated from social media platform is an example of unstructured data. Semi-structured. These data resources have partially structured formats. They can be easily processed and managed. A few examples of semi-structured data are XML documents and NoSQL databases. Elements of big data. Doug Laney initially described big data as the collection of 3 V's, adding a 4V later. Big data defines the enormous volume of data. Velocity is the speed of the data which is collected into databases of the organization. Variety describes the different formats of big data. Veracity refers to the presence of noise, biases, inconsistencies, and abnormalities in the data source. Volume. The data is generated from a variety of sources. For example, business transactions, social media information, data generated from sensors, and other day-to-day device-based communications. As of now, 2.5 quintillion bytes of data are created every day as the world steadily becomes more connected with an ever-increasing number of electronic devices that's only set to grow over the coming years. Velocity. Information is being created at a much faster pace than before, owing to the increasing number of sources of data production. This means that efficient ways of storage and real-time analytics is required for such data. Real-time systems such as railway bookings, social texting, and sensor tokens are producing new data elements every moment. For example, the New York Stock Exchange generates 4-5 TB of data per day, and Facebook data grows at 100 petabytes per annum. 90% of the data in the world today has been created in the last 2 years alone. It is equally important to manage this velocity. Variety. The data may be created in any form, perspective, structure, or context, which means that the associated data resources can be images, weblogs, audio, video, or sensor data. The database used should be able to process and store any of these formats. Apart from these elements, other elements also exist in big data. These are veracity, variability, and complexity. Veracity. IBM presented the idea of a fourth V, that is veracity. Veracity in big data refers to the presence of noise, biases, inconsistencies, and abnormalities in the data source. It is important to handle these factors to ensure that the analyzed results are free from any possible errors. Variability. Next is the lack of predictability or the variability associated with the flow of data resources. The velocity with which the data will be produced or generated is not constant. Any trending topic can trigger a hike in the frequency of data generation. This will increase the complexity involved in scaling those data resources. Complexity. This component deals with the idea of the complexity involved in establishing hierarchy or relationship between the variably sourced data of different formats and sizes. Such relationships among the data resources are required to ensure that accurate statistical analysis is performed. As data can come from multiple sources, it is difficult to establish a clear link or relationship. Sources of big data. The sources of big data should be recognized and classified to make their best use. The sources, which are media, cloud, web, IoT, and databases. Media provides quantitative and qualitative insights on customer preferences, behaviors, and trends. Online social media platforms include Facebook, Twitter, and etc. Cloud is a major, efficient, and economical source of big data. Web is another enormous source of big data. Internet of Things. Devices such as medical devices, video games, cameras, and etc. are used to collect big data. Databases are other important source of big data. For example, MS Access, Oracle, SQL, Amazon Simple, and etc. Building blocks of big data analytics. Big data analytics allows the industries to process the huge chunks of data and use it to find potential opportunities. There are 4 fundamental building blocks of big data analytics as shown in the figure. Hardware is the foundational layer of the big data stack. It includes all the systems and subsystems that are required for providing computational, storage, network, and interoperability capabilities. Second layer is the software layer that contains software resources to support big datasets stored at the hardware level. Software tools may be data mining tools or statistical analysis tools. Data management layer contains tools to provide a defined context for obtaining compliance and security. End user includes experts who implement the capabilities for big data analytics, along with the business users who harvest the benefits of faster analytics and access capabilities. Benefits associated with big data analytics. The true potential of big data lies with its ability to process any form of data. Big data analysis allows the users to solve issues such as cost reductions, optimizing the product development and manufacturing, and time resource optimization. The benefits of using big data analytics are: big data analytics can help companies save money. Tools used for big data analytics can enable businesses to make faster and better business-related decisions. Big data analytics tools help a business to create new products and meet the demands of the customers. Big data analytics helps one understand current market conditions and helps predict the future of the market. Big data analytics are used by business for performing sentiment analysis, monitoring and improving their web presence. Challenges associated with big data analytics. There is a long journey to be covered by big data analytics, as there are some challenges associated with it. The challenges are as follows. The high rate of data being generated is difficult to be dealt with. The number of experts required for big data analytics is far more than available. Accurate analytical insights need expensive tools. If the tools used for analytics are not scrutinized properly, data may get exposed to high risks and vulnerabilities. Technologies related to big data analytics. The concepts associated with big data analytics are as follows. Traditional business intelligence involves collecting, analyzing, and processing data. Data mining involves analyzing data and extracting information from different points of views. Statistical applications are algorithms to identify and process data which is based on statistical principles. Predictive analysis is done on the basis of movements and information gathered from the databases. Data modeling applies multiple what-if scenarios with the help of different algorithms to various datasets. Why do we need big data analytics? We need big data analytics for two reasons. Increasing size of data and challenges with traditional data analysis approaches. As per estimations, per day around 2,050 petabytes of data is being produced. Also, the techniques used in traditional analysis have a limited scope of schema, architecture, relationship, and type of data. What is trending in big data analytics? Big analytics is being used for many years now. Some practices have become outdated while some have become very popular. Big data analytics related technologies and trends include Hadoop, data visualization, mobile analytics, machine learning, and data analysis with R. Hadoop. Hadoop is a ubiquitous, open source, and a fault-tolerant system that organizations use for big data-related operations. Hadoop File Distribution System. Yet another resource navigator. MapReduce. Data visualization. Data visualization refers to the process of presenting the information and knowledge gained from raw data resources in a visual or graphical format. The graphical representation of information helps the business organizations to answer a majority of their queries related to business process optimization. Mobile analytics. Mobile analytics allows us to measure or analyze data produced by various mobile applications and websites. The data generated from smart devices is used to gain information regarding market trends, customer preferences, and other crucial insights. Machine learning. Machine learning is the ability of a machine to retrieve, study, and produce predictions on the basis of the data resources available. It uses different types of algorithms to retrieve useful insights from the data coming from the data resources. Data analysis with R. R is a high-level programming language and software environment which is used for statistical analysis, graphical representation, and reporting. It is considered to be the most powerful platform by statisticians, data analysts, researchers, and marketers who use it to perform retrieving, cleaning, analyzing, visualizing, and presenting data for data analysis. It consists of a large number of functions, such as statistical modeling, graphics, and data manipulation. Module summary. This concludes the introduction to data and big data module. Let's take a few minutes to summarize the key points of this module. Big data has existed throughout the fascinating and revolutionary journey of computing. Big data is the term used to describe large data sets. The data contained in it may be structured, semi-structured, or unstructured. The four V's in big data are volume, velocity, variety, and veracity. In addition to this, value, variability, and complexity are also important elements of big data. Big data analytics. Big allows the industries to process the huge size of data and use it to find potential opportunities. We need big data due to increasing size of the data and challenges in dealing with this enormous data. Hadoop, data visualization, mobile analytics, machine learning, and data analysis with R are some of the new trends in the big data analytics. I will pause for a few seconds to allow you to read it. Thank you.